Okay, good morning. Sorry. So, starting up with a new chapter today. Well, sleep it. Yeah, yes. Very So the tude given for you consisting of three chapters which are falling under physics, all three connected one after the other. Alright. So the resultant force, turning effect of a force, and then equilibrium. These three topics are taken over there. Okay. So all three given in one tude, since all of them are connected. So one after the other we'll be learning, and then some of the chapters we skip, and I told you that we will be separately taking, especially the chemistry chapters, on a long hour, a seminar, probably we'll be having it on this month. Okay. So you have to join accordingly then, right? So the ninth chapter we are starting up today, that is the resultant force. Resultant force. So the mind map related to all three chapters are given for you in the next page. Let me take the resultant force first. Here we speak about two topics. First, what is resultant? What is the concept of resultant? How to find out? And what are types of resultant? A very simple lesson will be done by today. Okay. Types of resultant we are taking collinear forces or collinear we say, and then parallel forces, inclined forces. Three topics we take. Resultant of two collinear forces, resultant of two parallel forces, resultant of two inclined forces. Inclined forces. So these are the topics you are going to take in resultant. Okay. So let's move into the lesson. What is this resultant? What is this resultant? Now, when we do works, probably to move an object, we apply a force. We apply a force. Depending on the force we apply, it would be moved for certain direction. Now, let's say I'm going to take this object. To this object, I'm applying a force in one direction. If that force is sufficient to move the object will be moving into the direction I'm applying the force. Correct? What is the direction I apply the force to? That direction object will be moving. If I'm pulling it towards me, it comes towards. If I'm throwing it, it's going away from. So what is the direction I apply the force? The object will be moving. Now let's say on an object, we're going to apply several forces. We're going to apply several forces. Set of forces we are going to apply. Now, collectively all the forces we consider. On behalf of everyone, what is the single force we can apply? This force is what we term as resultant force. So instead of all the forces, one single force we apply, that is called the resultant force. Something like, we say man to Superman, simply, right? Tens of men at once, what the work done could be done by Superman. That is the concept, right? Okay. Superman and all in real life, we don't know how much they are real. Okay. So within the frame, whatever the things they are showing, it is not real. So simply the concept is Superman can do the work done by many men. That is the idea. Right? Okay. So likewise, what is the single force? One force you can apply instead of all the forces acting on one object. This is called the resultant force. Okay. And this resultant to be found, not only the magnitude we take, we have to consider the direction as well. The reason is force is a vector quantity. Force is a vector quantity. Vectors, they got magnitude and direction both. Vectors, they got both magnitude and direction. They got both magnitude and direction. There is a magnitude, a numerical value, and a direction also considered. Example, let me take an object like this. I'm taking an object here. On this object, I'm going to apply a force. I'll mark it as F1, F2, F3, F4, F5. 5 forces I have taken in this object. I took 5 forces. All 5 forces here will have different directions. Can you see? not the same direction. Length of the arrowhead, length of the line shows you the magnitude. Arrowhead shows you the direction. Arrowhead shows you the direction. Okay. And you see, different forces are there. Let me consider my direction here as plus. This is my positive direction. Look at this. In that case, F1 should be plus. F2 should be minus. F2 should be minus. F3 should be, sorry, F3 should be minus. F2 should be plus. F1, F2 should be plus. F3 should be minus. And then F4 should be plus. F5 should be minus. Correct? So what is the considered direction should be taken as plus, opposite direction should be taken minus. And remember, these forces we are concerning only in one plane. Maybe horizontal or vertical. Horizontal or vertical. In this way, we don't need. But let's say if it is connected around a pulley, then ultimately the same direction should be moving. One direction only. And at the end of all, one direction will be considered. Apart from that, two different planes, we can't take plus minus. Same plane or same direction, opposite direction, you have to take plus minus. Got the idea? Okay. So let's have an example. Left to right, up and down, north to east, north to south, north to west, north to east, you can't take. East to west, east to south, you can't take in one plane. That's two planes. Two planes. So if two planes are there, you can't take plus minus. They have to be considered separately. Okay, in our level that we are learning. So you see, resultant is taken in this way. So when you want to find out the resultant here, let's say I consider this direction. How do I find out the resultant? F1, F2 should be plus. This is also plus, but usually the first letter we don't mark plus. If it is minus, we have usually plus we do. 1 means plus 1, right? 2 means plus 2, but we don't write plus, right? So F1 plus F2, F3 when you take, it has to be minus. F4 should be plus, F5 should be minus. Summation of all, it is what we take as the result. So you see, not only the magnitude we take, we consider the direction as well. So magnitude plus direction, both together we are finding out whom the resultant force. Got the point? Okay? Right. So now this resultant, we find out the resultant forces. Okay? Resultant forces under three categories. Right? We find out the resultant forces under three categories. What are the three categories? One, collinear forces or collinear forces. Right? Two, parallel forces. And number three, inclined forces. Right? Inclined forces. So we are finding out the resultant of collinear forces, parallel forces, inclined forces. Collinear means one line. Collinear means one line. On one line, the forces. On one line, the forces may be the same direction or opposite direction. One line. Parallel means parallel to each other. Parallel to each other. Okay. So we mark it like this. One line. And this is parallel. You can see parallel. And here, incline means in two angles. Two angles. So just let me mark some arrowheads also. It may be the same direction or opposite direction. So, collinear forces, one line forces, parallel to three lines, parallel to each other. Inclined, no, not parallel, not collinear, it's in two different angles. So, we calculate only the first two. Third one, no calculation, we are just going to draw diagram. We're going to draw diagrams. So, here we calculate the steps. So, accordingly, the resultant we find in this way, one by one, we have to take. So, let's go to the tube. Resultant force, we write down. That's right. Online has got the good side. When more than one force is applied when more than one force is applied on an object. When more than one force is applied on an object. When more than one force is applied on an object. The single force that gives the same result. The single force that gives the same result as that of the single force that gives the same result as that of all the contributing forces. All the contributing forces is known as the resultant force. Is known as the resultant force. Okay, is known as the resultant force. Right. Go to your right hand, please. Take the topic. Unit 9, resultant force. We straight away write on the right hand board. Since we have some questions, we have right. Go to your right hand board, take the topic. Resultant force. Unit number 9, resultant force. I will mark this down. Quickly mark this down. Yeah. This one. Yes. This part. Take the topic, unit number 9, resultant force. So resultant force and the unit is R. Not the unit. Unit is N, Newton. Symbol is R. How about the marks? last time. I reduced.
It's a subset.
Yes. You can't be saying that. Yeah, ignorance, can you see? Ignorance. Are you serious, right?
Fast.
No, oh, estimated. Don't play fool, okay? How about the marks? Marks. Term exams. Got the marks? Hey. Asir? Second term. Didn't do it. Rakib? Marks. Fine. Now this resultant we are going to take in different topics. Okay. First I'll take the resultant of collinear forces or collinear forces in one direction, one line. And I'm going to divide this into two topics as the same direction and opposite direction. Same direction and opposite direction. Look at this. I'm giving you the general ideas. The general concepts are what I'm giving you here. Okay, the general concept is what I'm giving you here. Okay. Okay. So calculations after that we will take. So get the idea first, get the concept first. Okay. So you see, same direction. I'm going to apply two forces. It's F1. Same line of action. Another force F2. Right? F1 and F2. And here, same line of action. F1, F2, F3. Same direction. So first thing you learn here, the side doesn't matter. Side doesn't matter. But I will use the word left side, right side for you to understand which side it is. But left side, right side, upside, downside, we don't add for the calculation. Side doesn't matter. Whatever the side it is, direction matters. To which direction the arrowhead is shown. That is what we take ultimately throughout the lesson. What is the direction the arrowhead shows? Right. Now you see, I want to find out the resultant of both of them. How do I take the resultant? The method. Resultant, arrowhead and mark. Sometimes at schools when you are learning, this arrowhead they not use. That's fine. That's not wrong. And marking this also not wrong. Both the methods you can do. Right? Basically, one direction if you show plus, opposite direction should be minus. So this plus minus ultimately we are using to find out the direction. So now, F1, F2, both of them are in the same direction, right? And that is the considered direction, right? So how do I take that? F1 plus F3. F1 plus F2, very simple. F1 plus F2. So should I need to mark plus here? Not must. It's not must. You write? Fine, you can write. That's not wrong. But practically as I told you earlier, when we are writing the numbers, we don't usually write plus at the beginning. In between we have. Okay, so it's F1 plus F2. And what about this? Very simple. The same way, all in one direction and one line. So I have to take it as F1 plus F2 plus F3. So it's better I make all of them in one line and in order. So I won't miss anything. So this happens in the same direction. Amma, don't be hurt. Right? And now I'm taking the opposite direction. I'm gonna take in the opposite direction. Let's see. I apply force here as F1 and here it is F2. It may be both push or both pull. Right? I can't straight away take which is minus here because two instances are there. What is it? Sometimes F1 may be greater than F2. At a time, F2 may be greater than F1. So I'm going to take in two instances if F1 is greater than F2. How do I take the resultant? Resultant should be in the direction of F1 then. So F1 should be plus, F2 should be minus. Correct? Look here, look here. Right? If F1 is greater than F2, F1 should be plus, F2 should be minus. And if F2 is greater than F1, F2 should be plus, F1 should be minus. So I take the direction of F2. F2 minus F1. F2 minus F1. Did you understand? No, I'm giving all the expressions. The value is given straight away, the same thing you have to apply. For example, 50 and 40, 50 minus 40. And 50 is in plus direction, 40 in the opposite direction. 50 minus 40. Got it? So then, if I'm giving only one example, it's hard to solve. I'm giving you the concept. So take the concept, take the art of the lesson here, any questions, okay? That's the idea. Got the point? So this is about the collinear forces or the collinear forces in one direction, opposite direction. Opposite directions. Got it? Okay? Right. So this is what you have to do. On your tube, you have two boxes. Right? Check out with the first page. First page means actually page number 3. Page number 3, there is a text box, right? Page number 3, you have a text box. Okay. Next to that, the fisherman shown there, pulling the net. So you see there, they are pulling the net all in one. They are pulling right in one direction. Have you seen ever anyone turning back, pulling in the opposite direction? If it is so, they will be beating up, right? Why? You have to pull in one direction. But this may happen. This may happen. Means all of them are there. They are applying. All of them are applying the same direction. Applying the same direction. But one person may be there turning around. He is pulling it in the same direction. That may also happen, right? You are pulling like this. Another person is there. He is pulling in this direction. Only thing is his position is changed. His vertical position has been changed, but the direction he applies the force is in the same. So that may happen, but the direction, that's what I told you at the beginning. What is the direction is what shown by the arrow. Okay, so arrowhead should be the same. So all of them are giving the direction, the force in the same direction. That may happen. So whatever, you see, that is an example where we apply all the forces in one direction. So there's a text box. There you have to take these two. Okay, same direction, these two you have to mark. And then go to the next page. Page number, just check out the page numbers. Page number 5. A pulling rope competition is there, can you see? Two set of people are there, both the parties are pulling toward their direction. So who applies the greater force, the sum of all the forces. Now let's say 5 people are in one direction. Total 5 in one direction, you have to take them added. Total 5 in the opposite direction, you have to take them added. Then both the directed forces, you have to take subtract. Why? Opposite to each other. Who gives the greater force to that direction, the others will be pulled. So this is opposite direction. Opposite direction. So there in that text box, what are you supposed to do? You have to mark the next part along with these two. Got it? Don't mix them. Keep spaces when you are writing. Got the point? Please go ahead and please mark your note correctly, properly. Go ahead. Mark the arrowheads properly, okay? And only these two in that first box. Right? Don't draw everything there. Two different boxes are given. Right there. How to write them as well? What is given in that red? Should be written too. Okay. Done with the next one.
In opposite direction, they have to lead to resultant force. That means in the opposite direction, they have to.
Yeah. Any number it can be. Right. So now, when we are doing the work applying several forces, it's always easy for us if we give a force this way. Let's say you want to move an object, you want to pull a push. So than giving all the forces in, as a pull or as a push, one being given a pull and the other one gives a push would be making the work easier. So one person gives a push on the object, the other person he gives a pull from the other side. Okay, so the work would be done more easily. Okay, anyhow, so that is how we apply the resultant force in our day-to-day activities. And all the examples I have given here in one plane, horizontal. It's always horizontal, it may be vertically also. A diagonal also it would be. The only thing is the direction you have to consider. Okay, so you have to read the tune. Okay, you have to make sure that you read the tune. We got page number 4. There's a small activity. Can you please quickly read that? Read the activity. Page 2. Right. What does it say? Now, what you do? Here, you will have a problem. Okay. You have your drawing. One side you are attaching the balance A and this fixed. Right? So the other side, let's say you have only one, you are going to pull by one. So when you are going to pull by one spring balance, the other side, there is another pull, another spring balance attached to it. It will be also stretched. So you see, as far as it is balanced, what it means, the force you are giving in one direction will be equal to the opposite direction. Correct? Something like that. Let's say there's an object. That object is being pulled by one person. There is an object. This object is being pulled by one person. And the other direction, another object, another person is also pulling. Okay. If the object is balanced, what do you mean by the force F1 and F2 when you take is equal? Correct? Equal. So now another person is there. He is also applying the force. So I'll take it as F2 plus F3 because two people are there. Both of them are giving the force in the same direction. But this person is still able to balance. Okay? This first person is still able to balance. Then what do you mean by that? F1 should be equal to F2 plus F3. Correct? Same way. Here there is a person. Right? And here there is another person. Right? Okay? So both of them are pulling. But you see now, both of them are moving in two different angles, right? Here we constrain one. But the thing is, he is pulling over there here. Second person pulling over there. B and C can be. But both B and C comes in what line can you see? Around a pulley, a wheel, it moves around a pulley, and both the forces act over there here as B plus C in one direction. Correct? Both of them might be pulling it in two different angles. But both the forces merge together act on the object in one line. And this is the direction it is acting on. Correct? And that direction is right opposite of A. If the object is balanced, what are we supposed to say? A is equal to B plus C. Got it? So we say that applying different forces from B and C. So we are going to change the forces continuously. B and C we are changing, and if it is still able to balance, what are we supposed to say? B plus C should be A equal to A. Equal in magnitude, opposite in direction. In this case, if the forces in one direction becomes equal to the total force in the opposite direction, remember the resultant will be zero. Why? Let's say total 100 newtons to the right side, total 100 newtons to the left side, then plus 100 minus 100 plus 100 minus 100 should be 3. Plus 1000 minus 1000 plus 500 minus 500 should be 0. So you see now net force becomes 0. Resultant becomes 0. If the resultant is 0, remember object is at rest. It won't be moving. So if the resultant is 0, object will be at rest, it won't be moving. So here I can say A is equal to B plus C. Got the point? Okay. So let's write down below the diagram. What it says, you can see. It could be seen that the sum of the readings of B and C is equal to A. Right there, A equals B plus C. And not it. A equals B plus C. So it is concluded that the resultant of the forces is given by their summation. So now here it is. Resultant we want to find. Can you tell me how much is the resultant in the first one? Look here. How much is the resultant? 300. How much is the resultant? 60. Straight away you can say. But how to write? That is what you learn here. Resultant. This is a direction. I'll take this plus. I'll take plus. You don't want to mark it. Okay. So 100 Newton plus 200 newtons. It has to be 300. Actually, plus means same direction. Still, I'm writing. Okay, if any of your readers say it's wrong, no, it's correct. If they say just don't write, that's okay. Even that is correct. Without writing this also, you can mark because plus means one direction. When it comes minus, it is in the opposite direction. That is the idea. Okay, so both the methods are fine. How about this? 20 Newton plus 40 Newton. It is 60 Newtons. 60 Newton and it has to be plus. Again, I'm telling you, no need to, it's not must to mark plus. You can just write without plus. Okay. And try the third one. I want you to try with a small diagram. Draw a small diagram for this. Okay. Just mark the forces given and get me the answer. Right. Did you find it? A child is pushing an object. A push should be shown properly by an arrow hit from behind the object. So let's say this is the object, a push. 5 Newton. Table? Yeah, it's based on a table. No, that's right. If you want, you can explain. Just not diagram. But two things you have to consider here. One, 5 Newton, this is the length, right? Actually, three things. 5 Newton, this is the length. Second one is 7 Newton, slightly more than that I have to take. Slightly more than that. Because usually the length indicates the magnitude. But we don't consider that much. If the question says use a scale, then you have to use. Use a scale means 1 centimeter to represent 10 newtons. Then 2 centimeters to 10, 20 newtons. 50 newtons you have to show by 5 centimeters. Likewise, scale. Okay, fine. Anyhow, the first point is slightly more than that, I have to take this. Second point, the push is 5 newton. So the push you have to mark as 5. And the pull is 7 newton in the same direction. In the same direction. And the third one, imagine this is the object now. Okay. I'm applying a force now. Okay. I'm applying a force. Is it correct? Just giving the force closer, is it magic to move? I have to point it, I have to touch it, right? And correct? So, why do I show that? I could see some of you when you are drawing the diagram, you draw like this. Yeah. Where is it touching? So, half loop. Is it correct? Wrong, totally wrong. The graphical representation is totally wrong. Why? If you could remember in grade 9, you learned there are 3 factors for a force in showing, representing. What are they? Magnitude, direction, which is the third one? Point of application, where the force is applied. So, where is the force applied? Where is the force applied? You have to touch the object. Got it? The arrowhead should be touched. Right? The length, the straight line should be touched. So, make sure when you draw the next diagram, don't make the Same mistakes. Okay, fine. So how do we find out the answer for this? Result. 5 Newton plus 7 Newton. So the resultant is 12 Newton. Right. Very simple. And this is what we spoke about under the opposite direction forces. Okay, opposite direction forces in the same line. And pulling rope competition is shown over there. We discussed it. And look at this. Please read that part. Quickly read.
Fully right. If one of the newtons is divided the other,
So we are using the same heavy. Right? Both the Newton balances we are using here are identical, okay? Both the Newton balances we are using are identical. Why? By the weight of the balances also it might be changing, right? If let's say one is more heavier, like he asked, one is more heavier than the other, automatically it would be moving to the. So we have to make sure both of them are same. Right. Now what do we do? I told you, can you remember? Two planes we can't consider plus and minus. But I told you if it goes around the pulley, we can. Why? Can you see here? It goes around the pulley. What is the force you are giving down? Is the same force giving at this point. But the thing is, we consider here it is a smooth pulley. The smooth, the word refers to no friction, or friction is very less. Can you remember the friction? Friction is the force opposing the motion of an object, right? Now, if there is a force opposing the motion of an object, listen, then the force you give would be balancing one. The remaining only would be acting. In that case, what is the force you are giving here will not be equal to this. If you have a friction. If you have a friction here, what is the force you are giving here will not be equal to there at the upper part. So that we consider the smooth pulley is being used here. So there's no friction. There's no friction. So what is the force given over there here by A will be equal to. What is the force given at this point will be equal to the. So you can see both being pulled in two directions. Now the question says A and B. Consider A and B. So A, let me consider A as my plus, B as my minus. A as plus and B as minus, let me consider. So A I am giving 4 Newton. According to the question, the activity, first we are giving 4 Newton. So it should be plus 1. Same 4 Newton you are giving for B, it should be minus 1. Then tell me what should be the resultant? Resultant is 0. What do you mean by that? Object is at rest. The trolley is at rest. Now what do you do? While you keep this 4 Newton, you're going to have a 6 Newton at B. Correct? 6 Newton on B. So 6 Newton on B means it should be minus 6, right? Minus 6, right? Then what is the resultant now? Minus 2 Newton. What do you mean by that? The trolley moves to B. Moves to B at how many Newton? 2 Newton force. Now again you are going to make both the sides 6 Newton. So it is plus, this is minus. How much is the resultant? 3. That means it is at 3. Did you understand that? It's a simple activity to show you what happens when both the forces become the same. Okay? Can you please mark it down here at this point? You have a small space there, right? Quickly mark it down. Fine. So now remember, when the forces are equal, we say resultant 0, object is at rest. We are giving another word here, equilibrium. The object is at equilibrium. Equilibrium means it is at rest. It is balanced. It is balanced. Actually, that is another chapter in the same table. The last chapter we have to take the 12th chapter is under equilibrium part. Okay, fine. Find the resultant. Equilibrium. Librium. Librium. Equilibrium. The word is there. Can you see it? It remains in equilibrium. Page number 5. Right. We have some questions. Can you get me the answers in the same method? Method is same. Get me the answers. Plus minus you have to conserve. Yeah. You can take the greater forces direction as a resultant direction. Or you can always use one particular direction as a resultant. That's fine. That's up to you. Get me the answers for all three. For the third one also, you have to concern it with and get the answer. Read the question and find the answer correctly. Did you all sign? Third one also.
The object is moving to that place to move the time. And object is moving to that.
That is already given.
Forces that we have Yes.
Yes. What receipt? Check it. Yeah, actually, we were discussing about a small seminar to be planned. You will get an update very soon. Both the subjects, inshallah. Probably by the end of this month. Science and business studies. Yeah, BS and science both together will be having a seminar. That's what actually we're planning on. You'll get the update quickly. Probably last Sunday, end of this month, Sunday we'll be having inshallah. Right. Find the resultant force in each of the following situations. Let me take the resultant to this direction. 10 Newton minus 5 Newton, correct? It has to be 5 Newton. 5 Newtons, right? And then here, let me take the direction down. 20 Newton minus 18 Newtons is 2 Newtons. 2 Newtons. Okay, 2 Newtons. Now let's say if someone says, so what if I take the direction to right? It doesn't matter. Anyhow, the final answer gonna be 5 Newton. How it works? Look at this. Let's say you take the right, then 5 Newton will be plus. 10 Newton will be minus. Correct? Correct? Now what will be the answer? To the right, it is minus 5. To the right, minus means, what do you mean by minus? It is in the opposite direction. Minus also says that your resultant is opposite. Then either you can leave the answer like this, or you can change this minus into plus. So when you change minus into plus, direction you have to change. You understand that? Now you can see the same answer. So no matter what is the direction you take, finally you can get the same answer. Okay? Right. What about question 3? You have an object placed on a table and you are going to apply forces X and 10. Question says, to the west 10 Newton apply, to the east X apply. Afterwards, it is drawn with the force of 5 Newton to the west. That means it is moving at 5 Newton to the west. Now the problem is west and east you don't know. No? That's the issue sometimes. So to the west it's moving. After applying the force, it's moving to the west means resultant is 5 Newton. Isn't it? Understand that after applying this 10 Newton and X Newtons, object is moving to the west. What do you mean by that? That is the resultant. That is the resultant. So we take the resultant here. Resultant X should be minus, 10 should be plus. So 10 Newton minus X. So X when you take here, wait, and then the R first, R is 5 Newton. So 10 Newton minus X, X you take here, then it goes 10 Newton minus 5, which is 5 Newton. Correct? X is 5 Newton. You have to show in that method. Okay, that is a method you have to follow. Okay, so please write, if you have just taken the answer, write it back again. Okay. You know, follow the steps. Follow the steps. So these steps you don't write on your paper. That is why you are reducing your scores. Okay. Right. Resultant of two parallel forces. Resultant of two parallel forces. Now you see, parallel forces when we take, they have two lines of actions or more than that depending on the number of forces taken. Okay. So you see here, on an object we apply F1 and F2 in one direction, same direction. And F3 is all there in the same direction, parallel, all they are parallel. This is the line of action of F1, F3, F2. Different lines of actions. What are we supposed to do? We are supposed to do to get the final resultant equal. Concept is same, one direction plus opposite direction minus. Only different from the previous one is there are one line, here several lines. One line, parallel lines are there. So F1 plus F2 plus F. That's it. And here F1, F2 in one direction, F3 is in the opposite direction. Let's say F1 plus F2 together is greater. F1, F2 greater. Then F1 plus F2, 3 should be opposite way. F1, F2 you take plus, F3 is minus F. F3 is greater, let's say. F3 is greater. F1 plus F2. F1 plus F2 is less. Now what I do? F3. From F3, you have to reduce the sum of F1 plus F2. So F3 minus F1 plus F2. Or you can write straight away F3 is plus F1 minus F2 minus. In that way also you can write. So simple, one direction plus y in the opposite direction, you have to take minus. So plus minus you have. Got the point? Okay, so that is how you have to find out the answers. So could you please mark it down? Within the same text box you can write. Sorry? Yeah. I'll give the papers to you. And those marks you will get it today. And also, please check out with last week's. Yeah, last week's grade 10 online class video. Watch the video. Okay, watch the class recording. They have discussed all those questions. All three papers questions we have discussed in the last class. Last week we didn't have the Saturday's class, right? So I didn't do any lessons for the Thursday's batch. We were doing a paper revision that the Scix papers, all three papers we discussed. Okay, so please go through the recording. Maybe by today or tomorrow, it's uploaded. Yeah, in your Google Classroom. Through the Google Classroom only, you can go to my YouTube channel because the links have been uploaded within a classroom channel. So it won't be public in my YouTube channel, only for the class students it is visible, so that you have to go through the Google Classroom. Okay. Grade 10 classrooms, you can get the works. Okay. They are all the videos have been uploaded. If you have missed any classes, please check through, right? So here the example given, you can see one person is pushing the car. When two people together, when they push the car, it is more easy with the work to be done because the collection, the summation of both the forces would be acting on. Okay. So that is the resultant here. Fine. Another activity is there. Could you please read that quickly and see what it says? Read. Mm-hmm.
How to keep the different spin balance and
Straight.
Yes.
Without toppling. And you have to take the balance also perpendicular, straight.
If it is
No, if it is the rod, balance should be kept perpendicular, not in an angle.
No.
These are the articles uploaded into your Google Classroom. Okay, I told you already. And recent cards have not been uploaded yet, it's uploaded soon. This is actually only one card is there, both sides printed the same. Related to the resultant course. Okay, all others in the image format, it is uploaded into your Google Classroom. So please take note. Right, and also the previous, the startup ones are there in the educate classrooms also. In both the virtual classrooms, they are uploaded. So you have to get to them, get it save it, and keep it in another folder. So it is easy for you to access. If you can't save it, at least you can on and off go to that, because if you keep the Google Classroom saved as an application, if you are keeping in your device, straight away whenever it is needed, you can go and check it. Okay, fine. So what's working here? What's the working here? You have to keep the rod straight, and the balance is also how to keep it perpendicular, not change the angle. Perpendicularly, and you apply two forces here, A and B. Right? And opposite, you are giving another force. You are giving the force at C until the rod is balanced. Until the rod is not moving to any of the side. At that point, you can see the force you are giving at A and B will be equal to C. Let's have an example, 5 Newton you give. Okay. So 10 Newton. Opposite side, when you are giving opposite direction, when you are giving 1, 2, 3, 4, it is not balanced. When you give 10 Newton, only it will be balanced. Let's say total you are giving 20 Newton. From 10 Newton until you go over 20 Newton, it won't be balanced. So at 20 Newton only it will be balanced. So that means resultant becomes 0. So A is equal to A plus B is equal to C. That means resultant is 0. Resultant is 0. Is that clear? So remember, if an object is balanced under forces, resultant should be 0. Resultant should be 0. So resultant 0 means object is balanced, object is at equilibrium. Object is at equilibrium, equilibrium resting state. Got it? So please mark it down. Just below the diagram you can write. And just draw a box around. Right. Resultant of two inclined forces. Resultant of two inclined forces. What is this inclined forces? Now, earlier we learned about the collinear forces, parallel forces. Collinear, one line. Parallel, two lines. But they are parallel. Here, not parallel, not collinear, unparallel. Also, in an, or as we say, inclined, in an angle. Right? So let's say this is the object I'm going to take. I'm taking three objects. It may be regular shape, irregular shape, whatever. And just I'm going to take two forces. You can see F1's direction is what I have taken here. This is the line of action of F1. It is the line where F1 is acting. This is the line where F2 is acting. F2 force is acting on this line. So it is acting on this, it's applied on these 2 points. So the same way, F1 and F2 are taking. Right. Now, no calculations you are going to take. No any calculations. What we do here, we are going to find out the direction. So it's something like this. This is the object. Okay. Now to this object, I'm going to give a force in an angle like this. Right? When I'm giving in an angle, what would be happening? The object would be moving straight. The object would be moving straight like this. Right? So this object there in an angle when you are giving a force, let's say if this F1 is equal to F2, F1 is equal to F2. You know what happens? Almost dividing the lines, the resultant will be acting. Equally dividing the lines of action, straight away the object will be moving. Object will be moving. Got it? Let's say somewhat I'm going to make F1 greater than F2. What am I doing? F1 I'm going to make greater than F2. Right? If F1 is more than F2, then the resultant will be heavier to the direction of F1. So from this line, F1 is greater, it bends towards F1, but it is not on F1. It won't come to the F1 line, but closer to F1, it will bend like this. Understand? It bends in this way. Got my point? Okay. Let's say if F2 is more, then what happens from here? If F2 is more to the line of action closer to the F1, F2's direction, closer to the F2's direction from here, it moves like this. Somewhere. So somewhere between this line. Got it? So if F1 is greater, between this line, there will be a resultant. The resultant will be acting on. If F2 is more between these two lines, oh wait. Oh, I have changed the letters, no? F1, F2. Right. Now, if F2 is more here, than F1, what would happen? The resultant would be acting with the direction of F1, F2 in this way. This is the resultant. Somewhere between this you can take. So between these two lines you can got the point? Okay. So between these 2 points you can take the line. So that is the result. So ultimately here, who gives the greater force closer to that person's line of action, the resultant would be acting. The resultant would be acting on. So F1 equals F2 straight. F1 more than F2, if that greater than F2, then the resultant should be closer to F1's direction. F2 is greater, resultant should be closer to F2's line of action. Clear the point? So no calculations we do here. Only by the direction, because calculations we can't do in grade 10 level since we need the angles and all that is in A levels. Fine. So can you please mark it down quickly? Use a different color pen to show the result. Can I get a ruler, please? Yes. Hmm. Yes, thank you. You drop me a message today to get added to the group. Okay, I'll give you my number is there in the group. No, mine. Oh, it's missing. Can you please mark the number? 0766 860 413. Okay, your name, school, grade, and syntax. Once you're done with that, please start with the next 3 questions. You can write the answers on your writing book. Yeah, go to your writing book, write the question and answer. Make it fast. Now, SQ papers are not given marks. SQ paper, that's homework papers, right? Correction are done. Marks are not given to that. Science papers should be given marks. Okay. So you have to check within this Scix. Okay. It's easy. Amma, ini Amma. Ini Amma Rashid. Ini mana? Ini. Amma belas. Dan ini. Ini belum. No, Amma was pretty. No one knew we were also today is that. How many days are you? Ayan. Amma Rashid. Umar Manas. Alias. You are there in the room. No, she has to work. Where did she go today? 22. Where did she go? Right. And can you all please just I'm sending you a paper. It's marked SQ 1, 2, 3. Right? If you have done those papers, SQ paper 1, 2, 3, 3 papers you did right. If you have done that, just put a correct. Right? You just mark correct. If you have done. I have the record. If anyone just marking it, kya bola? You have to just put a tick if you have done those papers. Right? Now today only SQ3 I gave you, right? SQ2 you did and we discussed during the class. Motion in a straight line. Okay. Fine. Or else you mark only the sides papers. No, don't mark SQ1s. First three don't mark. The next three, sides 1, 2, 3. Look at your paper and mark the scores that you have got. Write your name and just mark the scores. Yeah. For all three papers, what is the mark you got? Just write. Mark. Hurry up, please. Why?
So only the marks, right?
Yeah. All the marks. Mark the scores you got there. And online as you do, what do you do? Just drop me a message with the first, second, third papers marks. Okay? Drop me a message, right? I hope we are done with that. Could you please check with the 3 questions quickly? Draw a rough diagram and mark the answers on the right hand side. Hurry up, please. Hurry up. No. Second one. Third one. Hurry up. First one done. Look at the first question here. There are 2 bulls. Rakib, who are there? 2 bulls are there. Right? First question. I just get a rough diagram. And 2 bulls, one after the other, they won't apply the force, right? Have you seen? One after the other, they are applying forces? No. Okay? Parallel. They are usually, mostly they are parallel, right? So, and is it a push or a pull? It is a push. Each of them are giving, one is giving 100 Newton, the other one 8 Newton. What is the resultant thing? 100 Newton plus 8 Newton, very simple. So it is 180 Newton. 180 Newton is the result. Question 2. When an object is held by Newton balance, I'll just take a diagram. Right? The reading was 8 Newton. So there's an object. This gives 8 Newton. Along with that, Another object is there. Along with that, another object is also added. And that says it is 500 grams. This is given 500 grams. What is the total force? What is the reading now? Look at this. Resultant you have to take downwards. This gives you the direct force. So 80 Newton plus both in one direction. With Newton, you can't have the grams. You have to convert the grams into Newton. How do you convert the grams into Newton? Grams you have to convert into kilograms. Grams you have to convert into kilograms first. How do you convert grams into kilograms? Dividing by 1000 because 1000 grams equal to 1 kilogram. Okay? Asal 1000 grams equal to 1 kilogram. So how do you convert grams into kilogram? Dividing by 1000. Okay? 1000 grams equal to 1 kilogram means you have to divide by 1000. Okay? Got it? And kilograms you have to convert into newtons. 1 kilogram usually we take as 10 Newton because the gravity for calculations we use it as 10. Gravity 10 means mass into gravity is weight. Weight equals mass times gravity that we have already learned. Weight equals mass times gravity. Weight equals mass times gravity. Okay. So mass times gravity. Gravity is 10. So when you take this, you have to multiply the kilograms by 10 to make it 2. Got it? Is that clear? Now, 500 grams, right? First, what I do? I have to divide this by 1000. So I don't want to write grams. Check it. I see, look here. 500 divided by 1000. I don't want to mark grams here. Dividing by 1000. Now to convert into newtons, I have to multiply by 10. Now I have the newtons. I have the newtons now. So 80 plus 500 into 10, 5000. 500 into 10, 5000 divided by 1000 is 5 newton. Correct? 80 plus 5, 85 newtons. How many newtons are there? 85 newtons. 85 newtons are there. Got it? 85 newtons. That is the second question now. Third one. A trolley is being pulled by two forces, one with 20 newton along the east and the other one with a magnitude of 15 along the west. Right? The west 15, to the east 20. What is the direction for move? What is the result? Now result I take this direction plus 20 Newton, yeah, 15 Newton. So 5 newtons to the east. So you have like moves to the east. Moves to the east at how many newtons? 5 newtons. 5 newtons. Got it? Now, these are the problems where you make mistake. When the grams, kilograms are given, you have to convert. You have to convert and get the answers. Okay? Quick one. And please go to your writing books. Please go to your writing books. We take the questions quickly down. Give me the answer for this quickly. Give me the answer for this. Roughly draw the diagrams. Get the answers quickly. Did you all mark? Mama, did you do rescue paper 1 and 2? 1 and 2 in motion and straight lines. The rescue paper 50 MCQ, 50 short questions with chemical based supply. Short questions with that like that paper, like the same like another paper. Yeah, and I have use. Anyone have any first unit? Rescue paper 1. Rescue paper 1. Select all the papers in order. Yeah. So, right. This is the first paper. Just tell me if you have done this. Have a look. Chemical base supply first paper. And this is second paper motion in a straight line. We did this in the class. Okay, I have to do it and we discussed in the class. Okay. And the third paper is what one will do. And this paper's answers you can get it to my YouTube channel also. Okay. Somehow you did first one. Second. Yeah. Second one. All you did. Have a very much. Next time you are going to okay? And okay, quickly get me the answers, please. Amra, which question you couldn't do? I just saw your message. Which question you couldn't do? I couldn't see the last question. Question 3. Oh. What we discussed over there here. Is that so? Yeah. Oh. That was yeah, you can do it alone. That 20 Newton to the west and 15 Newton to the 20 Newton to the east, no? Yeah, 20 Newton to the east and 15 Newton to the west. So according to the direction, just take them, okay? Final answer will be 5 Newton to the east. And you can forward your answers for these questions. You can forward the answers for these questions. Check out the answers, please. Check out the answers. Guys. How about this resultant here? Resultant, let me take to this direction. 15 newtons will be minus. Correct? 6 would be plus. 3 will be plus. Okay? What is the answer? 6 plus 3, 9. Minus 15, minus 6. So, minus 6 to my direction means opposite direction I have to take it as plus 6. Correct? Yeah. How about this? Let me take resultant down. 150 will be minus. Okay? Minus 150. 200 will be minus. 400 will be plus. Correct? So, minus 150, minus 250, minus 200, minus 350. Plus 400. Answer will be plus 50 Newton down. Correct? Plus 50 Newton down. Okay? You have to take the summation. And here the resultant, let me take this direction. 250 Newton plus 170 Newton plus, and another 170 Newton is there in the opposite direction, minus. So 170 to 170 cancels off. What is the answer? 250 Newton to the same considered direction. How about this one? Resultant should be definitely down because only downwards the forces are there. 2 Newton straight away given. You can apply 2 Newton plus 5 kilograms given. I told you kilograms, grams you have to convert into newtons. How do you convert? 5 into 10 Newton you have to take because 1 kilogram is 10 Newton. 1 kilogram is 10 Newton. So 1 kilogram 10 Newton, 5 kilograms into 10, 50 Newtons. Correct? So 5 kilograms 50 Newton plus 2, 52 Newtons you have to take. You can't add 2 plus 5, 7. You can't take it as 2 plus 5, 7. That is wrong. Got it? How about the fifth one? I haven't given any lines down. But remember, any weight, any masses hanging down, the weight will be acting down. So the weight will be acting down. Upward there is a force. Upward there is a force. Downward 2 kilograms are there. 2 kilograms means kilograms how do you convert? Multiplying by 10. So the weight is there here 2 into 10 Newton. Got it? You understand that? There is a weight, 2 kilograms mass. Downwards due to gravity, 2 into 10, 20 Newtons acting downward. So plus 20. Upward minus 20. 20. Downward plus 20. Upward minus 20. So what is the answer? 0. So resultant 0 means object is it moving? It is at rest. It is balanced downwards. Okay, it is balanced downwards. Resultant is 0 here. How about this? I'll take the resultant here. So 700 should be plus 150, 150 for both the tires. It is given. Okay. For both these 150, both these 150. It doesn't say each tire 150. Collectively is given. So minus 150 minus 150. 700 minus 150, 150 means 300. So it gives you 400 newtons. 400 newtons. Okay. Resultant is 400. That means the drive force would be 400 newtons. And here the resultant will take down. Downwards it is 500 Newton, that is the weight. Upward two forces are there, each 250 Newton. Minus 250, minus 250. Yeah. Then so minus 250 is minus 500, plus 500 minus 500. Resultant is 0. Here also the object is rest. Object is rest. It is not moving. So something like the board when we take, it is hanging on over there by the nails or by the triggers. Okay. So it's bolted. Upward two forces, downward the weight. It's not moving because it is balanced. It is balanced. So balancing by the forces at either side. Maybe 2, 3, 4. It is according to the length, number of nails are or number of boltings are given. So it is balancing on. Did you understand that? Okay. So accordingly, few questions related to the forces. Related to the forces. Okay. So another SQL paper will be getting probably within this month, maybe next week or the following week, where you have to write answers at home and submit the papers. Okay. Most probably it might be from the forces. From the forces, you will get a question paper. Okay. So please do refer them. And all you guys got the papers today, the Scix papers. Check with your answers. Check with your answers. We'll forward the answer sheets to the class groups. Or we'll be uploading it to the Google Classroom as well. Today. So not today. Within a couple of days, inshallah. Before the next class, you'll get it on. Make sure you go through them. And see. Now, additional works I told you we are doing to see a progression. Okay. You have to work for that. You can't just be coming and making a tactic book here. You have to work, you have to learn and come. Say, learn and come. Okay. If I can see the same way you are repeating the works, I have to take a decision. I have to take an action. Right? Please make sure if I'm asking you to refer and come, refer it. So you can do the paper easy. So next week onwards, e-test would be also started. Okay, e-test would be started from next Wednesday onwards. So please do them as well. Those marks are also being recorded. Okay, those marks are also being recorded, and at a time we'll be taking all the e-test at once, and we'll be discussing that also. Okay, but you can go ahead the discussion if you have done the paper on. So make sure you do. And without you guys being done, it's useless. I'm sending you the marks and the answers all. So you have to do it. Okay. So if you have missed any of the papers earlier, once we send all the papers, you can just go through. Check with them. Now from your end also you have to do a work. Nothing is impossible until you do it, until you step on it. You have to make it possible. So nothing is hard. Give a time and do it. You can't say I can't. Everyone does, right? So why can't we? That is what you have to think. You have to. So make sure you give your maximum effort step by step by step. Gradually you have to improve. At once you can't do everything. Gradually. That is why one by one I'm introducing you to do this. Okay. So now you have to catch up and go ahead. So cover up all your lessons. If you missed any of the lessons, go through the class recordings and do cover it up. Okay. In future, you'll be getting continuously the questions to revise on. At that time, you should not be regretting. Okay. And you should not be going back while others are moving on. So you have to go along with. So every one of you, make sure refer. Otherwise, pointing out, I have to give some papers. You understand? Which you have to definitely do within the class. Which is easy, you have to decide. Clear the point? Fine. See you then. Good afternoon. Salam. Salam.